Hello friends, I am Anjali Bhosle, Assistant Professor, Department of Statistics at Rajarshi Chhatrapati Shahu College, Kolhapur. Today we will discuss about measure of central tendency. Introduction. In the last two chapters, we studied different types of data, methods of summarizing data, and how they can be represented graphically. In this chapter, we are going to study about the constant, those who are occupied an important place in statistics, which are used in several statistical tools and analysis depend upon it. Concept of central tendency. The word average is very commonly used in day-to-day life conversation. We often talk of average speed of car, average profit of the year, average age of employee, average income and average mark. So our next point is types of average. There are various averages of measure of central tendency. Among them, the commonly used measure of central tendency in business are classified as averages. There are two types of averages. First one, mathematical average, and second is positional average. In mathematical average, there are three types. First one, arithmetic mean. This is called AM. Second is geometric mean, GM, and third, harmonic mean, HM. So the positional averages, there are two types. First one, median, MD, and second is mode, M dot. So arithmetic mean is the most common type and widely used measures of central tendency. It is also called as mean and abbreviated as AM. Definition. Arithmetic mean is defined as sum of all observations divided by total number of observations. In other words, arithmetic mean is defined as the ratio of sum of all observations to the total number of observations, and it is denoted by x bar. Thus, x bar is equal to sum of observations divided by total number of observations. Computation of arithmetic mean. This is case first, ungrouped data or individual observations. Suppose if x1, x2, x3 up to so on xn are the small n values of on the variable x, then the arithmetic mean is denoted by x bar and is defined as x bar is equal to x1 plus x2 plus x3 plus and up to so on plus xn divided by small n, and x bar is equal to summation of xi divided by n. Then our next case, second, group data. First one, discrete frequency distribution. If we are given xi and fi, so I running from 1, 2, 3 up to small n, be a discrete frequency distribution. Then their arithmetic mean is defined as x bar is equal to x1 into f1 plus x2 into f2 plus x3 into f3 plus and so on plus xn into fn divided by their frequencies f1 plus f2 plus f3 plus and up to so on plus fn. So the x bar is equal to summation I running from 1 to small n fi into xi divided by summation I running from 1 to small n fi. Therefore, x bar is equal to summation I running from 1 to small n fi into xi divided by capital N. And therefore, the capital N is equal to summation fi. And next point is continuous frequency distribution. If we are given that continuous frequency distribution, then we consider the midpoint of each class. If m1, m2, m3 up to so on mn are the midpoint of the classes with corresponding frequencies f1, f2, f3 up to so on fn, then their arithmetic mean is defined as x bar is equal to f1 into m1 plus f2 into m2 plus f3 into m3 plus n up to so on plus fn into mn divided by f1 plus f2 plus f3 up to so on plus fn. So the formula of midpoint is equal to upper class limit plus lower class limit divided by 2. This is the formula of midpoint. So the x bar is equal to summation of I running from 1 to n fi into mi divided by summation I running from 1 to n fi. Then the x bar is equal to summation I running from 1 to n fi into mi divided by capital N. Therefore n is equal to summation I running from 1 to n fi.